Let's get started. Welcome everyone to Baseline Tech Talk Tuesday. This is Dan, episode what?
Oh crap! I did not.
See,
look
I wasn't
at that
prepared
one.
because I thought
I
you would
know
know.
we weren't. It's episode 29.
29, and this will be part 2 of Dan's discussion with Lisa last week on this site. So we're going to take kind of move it to the next level. And for anyone joining us for the first time, you can catch all of the replays on the Baseline YouTube channel. That's Baseline Web Training, all one word, on YouTube. Catch all of season 1, all of season 2, as well as all the helpful how-to videos that Dan's been creating. And Chris Wright's on vacation, so Dan and I are going to take it today. And Dan prepared this. Like I said, I just got off a yachting trip, so I'm going to improvise and ask questions because the site is going to be new to me because I wasn't involved last week. So hopefully I can add some flavor just right off the cuff.
Cool. So cool. If you didn't catch last week, we talked about an 800 acre planned community in Arizona. And I've got some slides I'll show you. And so you could watch last week's, but let's just I think I've got enough to just jump right in. This is really kind of blown away some people that aren't used to some of the stuff in the Southwest. This is very typical for the Southwest, Texas back down to California. Sparsely planted plant material, lots of mulches, drip irrigation on just about everything. Turf is in very central, important places, but not everywhere. So this is a pretty typical landscape in there. They've got the turf around the clubhouse. Here's another typical city streetscape. What I really noticed last time was that the swales, right? Because in Arizona, they'll get these monsoonal rain events and get 3 inches of rain in a day, and they need to manage it. So they've got lots of contouring in there. And then this is about as dense as it gets, right around a play structure. So very low water using on the landscapes. So that's kind of what they've got. So they've got, here's what went in on the final build out. Again, this is a little bit of a light recap from last time. So there were 6 base station 3200s that were pedestal mounts. They had one substation, 1 flow station, and then 8 network modules. And then they have 19 water meters. So they had 19 flow sensors and 19 master valves and over 1,000 zones. So I think just off the bat, 1,000 plus zones on 6 controllers. That's pretty impressive.
And I'm just looking here because of the 8 module count, doing the quick math there. Each of those control devices, the 6 3200s, 1 substation, 1 flow station adds up to 8. So by process of elimination, each one of those looks like had a cloud module.
Absolutely right. That's absolutely right. Yeah. And then that's how they communicated and share that data. Now, originally what they planned on, and this is what I really wanted to focus on today, was the difference between what they intended in the hardware they intended to install and versus what they installed, and then talk about the design intent. So the hardware that they planned, let's back up to their design intent. What was their purpose? Well, they wanted to minimize the number of controller interfaces. That's the first thing, right? So the fewer controller interfaces we can have to maximize it. That's for efficiency of cost, but also for management. They wanted to be able to get to these devices remotely. And then they wanted sensor input from what's going out in the field to help manage it. That was their basic stuff that they're after. So with the 6 controllers, wow, that's awesome. They're doing that. The hardware they had planned on was using Ethernet radio modules. They'd planning on each one of those in each of them. And then they planned on using an Ethernet hub to have those radios talk to that hub, and then that hub connect to the internet. So show the internet connection over the radio.
Yeah. And it would probably, again, this is probably has no bearing, but they likely would have needed a radio module in the hub. So probably was 7 modules, right, 1 for the hub plus 6 for the 3200s.
Good catch. You're probably right. Yeah. Right. And then, the same 19 flow sensors, the same 19 master valves, the same 1,000 plus zones, right? So, but the difference though, that there's like 3 major areas that I wanted to talk about. So the build out versus what they actually thought they were going to put in, there's some differences there. So the first one that I wanted to talk about was, here's the first change that came about. So they added a phase. Their partway through the construction, and the construction took 2 years from beginning to final, right? So that's a lot, and then plus the planning phase. So it was years. This was definitely years in the making. And they added this phase that I have circled here. Well, they've already got controllers in, they've already got water meters in, they've got some of the main lines in. What are some solutions? So Andy, what if we don't think about a non-baseline, what's the first thing we do? Is probably another just controller, right?
Find the closest controller to wire and see if you can add on to it.
Yeah, that's right. So run new wire. Right. Well, we've got lots of street crossings, and it's anything's doable, but the easiest is to add a station for this one. And the substation was able to wirelessly connect to a nearby 3200 pedestal that had capacity one. So each 3200 can handle 200 zones. So they were able, and they had capacity on that one controller. It wasn't fully utilized. And then they didn't have to run the wire for it. And it was economical and relatively easy to install. And right. Then the substation has its own wire path.
Yep. And then the other option would be just drop another 3200 controller.
Yeah, right. That could work too. It would. Yeah. Well, now that does add another interface. So if we come back to their design intent, fewer interfaces, this still maintains that fewer interfaces, that intent, because we haven't added another controller. So that was probably the first one, was the substation was their first one on their change that came up. And what I kind of thought was really interesting and cool was that the ability to adapt on this one on the fly, relatively easy. Now, do you see, Andy, do you see more substations on new installation or retrofits?
Typically retrofit,
yeah.
Because the retrofit was pieced together over time, where there was a controller and it was 24 zones, and that's all it had. They expanded, then they dropped another controller and another controller and another controller. And oftentimes all of those multiple controllers can have one water source, and that becomes a programming and a scheduling nightmare. So there comes the substation can come in and solve that problem, take 5 controllers and make it one irrigation system.
Right. Yeah. So in a way, this is kind of it's almost a retrofit, it's already, the design's is already on the ground, and this comes up like, what are we going to do?
Yeah. I think, Dan, maybe the best way to look at it, it's a problem solving tool.
Yeah. Yeah.
Like the substation was used in this instance to solve this problem of an expansion that didn't quite, match up. And retrofits is typically where we solve more problems like that. Because new construction, we can oftentimes plan for it.
Right. Right. And this was a change of plan. So that fits in really well. Awesome. Okay. So here's another one that was a little more complex, and it took me a while to kind of figure out a good explanation on this one. So the original intent on this one was to have 1, maybe 2 water meters, 1 to 2 water sources per controller. So I've simplified it to just 1 and 1. So controller D was supposed to have a water meter and a master valve and a flow sensor connected to controller D, and controller D's separate mainline. Controller F, separate mainline, separate wire path, master valve, flow sensor, supposed to be separated. Okay, that was what they intended to do. And then controller C all the way through the rest of the project. Now, here, this is something that this kind of stuff happens, and this is what actually got installed. What happened was the wire path for controller, the master valve on controller D wasn't connected to controller D. It was actually connected to controller F. Now, how does this kind of stuff happen? Well, it's pretty complex, right? You got 1,000 zones, and I've been a contractor, and crap happens. And this is definitely crap. This is not pretty. So let's take a minute and unpack that. What's the impact of doing this, of running the master valve to a different controller?
Yeah, well, eventually that controller F would run out of zone count.
Well, it's actually, the zones are still connected to controller D. It's just the master valve.
Oh, just the master valve only. I see.
Yeah, that's even worse, huh?
Well, you can always, tell controller F when it should come on due to when D is scheduled.
Okay, so basically go in there.
That would be a pain.
Oh, beyond a pain, right?
Yeah.
I mean, because we've got the capability, but right. So we could program a window in which controller F opens D's master valve.
Right.
That's
Essentially,
ugly.
D and F now have to talk to each other because they're sharing a common, piece of data, which would be that master valve.
Yeah.
Between
and the flow sensor, like flow data. Is the flow data going to controller F or is it going to controller D? We've got that issue. Or realistically, people might bypass the master valve, or see if I'm the contractor. If I'm the contractor, I'm really sweating it because someone may say I'm obligated to now dig up a quarter mile, half a mile of trench, wire that's installed, maybe landscaping a couple street crossings. I'm obligated to fix that problem, right? And that's going to be really expensive too. If you just kind of think about the razor thin margins that a contractor has.
Mm-hmm. And this is why so often you may go up to that master valve and it's switched manually open because they're not using it because they didn't have any other choice. They just said, you know what, we're just going to open it up and it is what it is. Right.
And that's probably what they were faced. So I think this was a really brilliant solution, and it's a great fix. Was they used the flow station. So the flow station is now communicating with both controllers. And then the flow station is now managing both master valves. So when controller F wants to open a master valve for controller F's mainline, it's only going to open controller F's master valve. When controller D wants to open it, it's talking to the flow station and asking for that information. And now the flow station would send the command actually to controller F and say, open D's master valve, and it would open it.
Right. Yeah, that is good because I can think it's nice that I didn't know what the design intent was going into this. There's no setup here, but I can see how there wasn't a plan for a flow station necessarily initially because they were all set up per each controller individually. And so introducing the flow station can solve that problem where they now need to be shared, but they weren't originally intended to be.
Right. And when Lisa and I were first walking through this project a couple of weeks ago, and she said, and a flow station, and I'm scratching my head. I'm like, you don't need a flow station because each controller can handle up to 8 master valves, 8 flow sensors. So that's not an issue. Mm-hmm. Why would we need that? And then when she explained this challenge here, I'm like, oh, now this is where I got my numbers a little bit wrong is this flow station is actually not in a cabinet. It's actually sitting in the base of the pedestal. Mm-hmm. So that eliminated one communication module. And then we had the communication module in there. We'll talk about communication that's coming up next, but there was a slight change in there. But I think that was kind of nice is they didn't need to set a new pedestal base. They could just mount that in the bottom of the pedestal itself.
Yeah. And really just for you guys watching don't have experience with the flow station, it's really a brain. So if you think of it that way, it's just another panel with an interface that is hung inside the pedestal and then connected with an Ethernet cable to the controller, to the 3200. And then we might talk about this, Dan, but because the 3200 Ethernet port would be potentially being used either by the radio or by the cell modem, there might be a switch in there as well that allows for both of those devices to connect.
That's absolutely right, because we need to split that communication a couple of different directions. So that same communication module can work for both the controller and the flow station and share it. Absolutely right. Yeah. So let's come back to the flow station. See, this was kind of an interesting use for it, but what are some other ways, maybe more common ways we'd use a flow station that crosses over? So, well, I think the one that I commonly would run into is multiple controllers sharing one water source. How do we know? And that's kind of what's going on here. We have multiple controllers sharing multiple water sources. But anytime the flow gets complex, and as you kind of put it, it's a flow or water resource brain manager.
Yeah, because the first common use case is where multiple controllers share one water source. But then you can have sub-metering and you can do bypasses. You can do more complex flow management with the flow station. It's not just a shared flow device. It does more than that.
Right. Cool. Good. Okay. Okay. Good deal. And then I had one other one. one other hardware change. And originally, they wanted, remember, coming back to design intent was to be able to manage this remotely. So to manage it remotely, they needed communication methods. So the original hardware they had planned on was to have each controller have an Ethernet radio in there and connect that to a radio hub. And then that radio hub would be then connect to the internet. So they'd be sharing an internet connection via radio for those multiple controllers.
Yeah. And Jim White just asked a great question from a couple slides back where you had the components, but we didn't have this visual diagram. And you can call it a hub, you can call it a gateway. Those words can be used interchangeably. Mm-hmm. And that's exactly what this would be, either Ethernet in and radio out, as was intended originally, or cellular in and radio out, et cetera.
Right. Yeah, absolutely. Absolutely. So what we're not showing the hardware that's in there, but within those pedestals, they originally intended on a radio. A couple of things about radio, and we'll probably take a minute to kind of talk about this, is radio is intended generally for line of sight. And generally, and to make sure that a site's going to work, we have a qualification or a survey process in which we want to test each location. Mm-hmm. And that'll help us understand the antennas and what everything looks like, right?
Yeah. Well, it's important to know too that sometimes flat sites have crappy radio, and sometimes sites with buildings, radio surprisingly works because it can, bounce or something. So doing a site survey for radio is almost a must. It's critical. Got to do it because it's very hard to assume, more likely to be wrong.
Yeah. Yeah. And this is kind of a pre-construction slide when just after they were doing grading and we're partway through, and radio surveys on this one can often be quite good because you can visually see, that line of sight. But the reality is that, there's 2-story buildings, block walls, which that wasn't going to be surprising, right? We knew that was going to happen. But what that also meant that you're going to have to place the antennas in very specific locations, and you might need some tall antennas. You might need some really tall antennas to get around these obstacles. Well, not really a problem, but here's an improvement that comes along. So remember, we go back 2 to 4 years to this initial planning process, and 2-4 years later, we've got, trenches are being opened and products being installed. Well, in that process, we came up with a new product. There's a new product, and that was the cloud server, the IoT network using the cell cloud module. So that essentially allows a cellular component to connect to a remote server. In this case, they're not talking directly from device to device like radio. Radio will have controller to hub. This one, we're going cell to a cloud network, and then they're going to share their information across that cloud network. So everybody's leaving the site, their data.
And I don't know for sure, but I would imagine that there was a discussion about which way to go. And I like to kind of remind people that there isn't one way that's better. There's just pros and cons of each, and based on who the manager is, who the owner is, what they want to do, how they want to maintain, what they want it to look like, take into consideration different variables, you can decide whether radio makes sense or cellular, but sometimes there isn't a better one. There's only what works well for this site for X reasons.
And I think that's why I was bringing this one up, is they didn't initially have that ability to have that conversation because we didn't have that hardware option at the time when this was designed. It came up, and then there was this discussion. Well, let's weigh that. And, there's some aesthetic considerations. Is there a financial consideration? What are the benefits of switching over to that? With all these different options, I kind of wanted to lastly talk about how we want people to navigate, or how should people navigate these decisions in that process, right? So knowing, is it radio? Well, you've got this new product. Will this work? Is it going to be better? Or we've got this problem with flow. How can we manage it? What's the best way for contractors and specifiers to navigate that with us?
Just to say between radio and cellular?
How do they figure this crap out? Do they need to figure it out on their own? Or,
Well, the
how
first
do
thing
we
we
get
have a
involved?
discussion about it, and look at all
With
the options, and
right.
then maybe look at who the owner is, who the maintenance contractor is. There's definitely, well, could be a little bit more easy button with the cloud module because you don't have to know anything about a radio or how to program them or how to maintain them or replace them. Because if something does need to be replaced, you need a little bit higher level of expertise in order to maintain a radio network. But once they're running, they're super, super solid, and then you could say, all right, cellular. Sometimes cellular is great. Sometimes it's not. We're using third-party technology. So we should take that into consideration, that what does it look like in 1 year, 2 years, 3 years?
Yeah.
Those devices may have to be changed, modified. So kind of discussing all of that and helping the prospective, either consultant, client, architect, et cetera, make a decision.
So essentially, the short of it is they don't need to figure this out on their own, right? This is that conversation that we're going to be involved in, and it may be, it's going to be different from that process, or that, if a contractor initiates it. So the contractor may have initiated the flow station one. They're like, man, this is ugly. What am I going to do? How's this going to work? They might start the conversation, and then the radio cell conversation might have come from another party. And then, but either way, we're going to get involved in that. And then we could, help out in pricing and work with the distributor partner on that as well.
Mm-hmm. And, people have preferences. If there happened to be a contractor in that area that was very, very familiar with radios, then they may have a preference for it because they know it. If this was a site where it was going to be a brand new user that really was at a level 1, they may want to do something that is, going to be simpler for them. So sometimes there's those things to take into consideration. And if anybody on here has experience or wants to chime in, feel free to either drop a comment or a question in the Q&A. I think, Adrian, you've got your hand raised, but I don't think we can pull you in live. But if you want to make a note on something, just either drop it in the chat or the Q&A and we can get it answered.
Yeah, nice.
I've worked with both. And they're really, like I said, there's one is not better than another. They both have pros and cons.
Mm-hmm. And I know I've talked with some people in different markets. And I think Tracy's talked about this in the Colorado market, that some of the one, I don't know which it is. It's either radio or I think it's cell. One or the other is more jammed up by gas and oil industry. So he always has a preference over one, and I forget which it is. Maybe one of our local Denver people can.
Yeah. And it is funny how I've seen flat sites that radio can be crappy. And I've seen sites with buildings that it surprises me. You go out to do a radio test and you're sitting there like, really? There's no way that we're getting the readings that we're getting. How could that be possible?
Yeah. Yeah. And good point. Well, and I think the other one that I thought was kind of important was that, we're always changing. The technology is changing, and we're trying to be on that cutting edge of technology. So it could be that, from when we originally designed the project to when the shovel's breaking the ground, things can change. Mm-hmm. And, I don't know what's going to change in this. Well, I do know a few things that are going to change in the next 12 months. I don't know all of them, but those will be things that, people might want to pause and say, would that help us out on this process?
Yeah. And it's funny when you drive around, let's just take, there's a new traffic light here in Traverse City. So I was just paying attention to it because it's a brand new signal. And right near the signal was a new pole with a new antenna with a Yagi. So somehow that light is, communicating somewhere else with radio. So this stuff is kind of around us all the time. It's not unique to, baseline. Radio technology is used all over the place to communicate.
Right.
So let's see. Don Barnes put in the chat, he used the flow station to open a master valve on a separate controller. Perfect. Great use case.
Yeah. Yeah. I when I was first an irrigation tech, I remember recognizing that to add master valves to projects was really challenging because, getting wire from point to point, and a flow station would allow you, is one of the tools that would allow you to bring a remote device in and still manage it properly.
Yeah. And especially too, if the water source originated far from where that controller is, and you want to add a master valve to a source that's a long distance away, you can drop a substation over there. Great. Well, if there aren't any other questions, maybe what are we going to be doing next week, Dan?
We're going to talk about 2-wire troubleshooting. So we've looked at it before. We're going to do some revisit, and it's something that seems to be really popular with people. So 2-wire troubleshooting and tricks and tips. Okay. That's what I meant to say.
I thought you were going to say take some trips to the site, and we're like, we're not saying that anymore.
No.
Very cool. Okay. Anything else we want to mention here on this one?
I think that gets us through the content that I thought was important today. So,
okay. Right on. Well, thanks everybody for this on this episode of Tech Talk Tuesday. And we wish you guys all smart watering through the rest of the summer. And thanks for joining us. Remember to tell a friend or a colleague, actually probably more like a colleague, about Tech Talk Tuesday. We'd love to grow the audience and help more people. So with that, Dan, I think we're wrapped up. Let's sign off and everybody go have a good week.
Hey, thanks everybody. It was good to see y'all.
Okay. See you later.
Bye.